Hello everyone, my name is Timothy Lee Grant and welcome back to another video on LeetCoding. So today we are going to continue our practice of learning heaps, getting better at heaps, moving forward on this particular topic until we get good at heaps, and then we're going to move on to a separate topic. Okay, so let us do as we normally do. We're going to minimize myself and then we're going to randomize and pick the next closest medium. Okay, so here we go. Randomize, randomize, randomize. Here we go. Closest medium is this one right here. All right, let's see what this one is all about. Okay, 2,944. Minimum number of coins for fruits. You are given an one indexed integer array prices. Okay, so we're given an integer array that's indexed at 1. Okay, that's a little bit strange. I thought, how do they enforce that? Is the first element of this prices array just blank? Is it invalid? Because there has to be a 0, right? So just to conform with the programming language specifications, there's no way to just like cut off the 0th index unless you just make that index invalid and it stores garbage or something like that. So that's a little bit strange that they said it that way, but okay, sure. Where prices of I denotes the number of coins needed to purchase the ith fruit. Okay, so I'm guessing that there is some kind of fruit. There's no fruit array or anything like that. So it's just the ith fruit. Doesn't matter what fruit it actually is or something like. Okay? The fruit market has the following reward for each fruit. Okay, so every single fruit has the same reward, and here is the definition for which the reward is. Okay, so for every fruit, each index in this prices list. If you purchase the ith fruit at the price I coins, you can get any number of the next I fruits for free. Okay, let me reread that again. So, if you purchase the ith fruit, so a single fruit at index I, which has the price, so let's say that price of I and I is 3, the third index, contains an integer which is 5. So if I have like 10 coins, I can purchase index 3 with 5, and now I still have 5 coins left. Okay, so I purchased index 3. You can get any number of the next I fruits for free. So can I get infinity of I plus 1? Is that what it's saying? Fruit. So the fourth index, I can just get infinity of those fruits. Is that kind of what this is saying here? Note that even if you can take fruit J for free, you still need to purchase it for prices of J coins to receive the reward. Wait, that's not free then. That's not free. It's free as long as you pay the price. Okay. Return the minimum number of coins needed to acquire all the fruits. Note that if you can take fruit J for free, okay, you still need to purchase it for prices J coin to receive its reward. And this reward, okay. So I think that means that if I get, let's just say the third index, and I purchase it for how however much it is, like 5 coins. I think what it means is I get the fourth, but I don't get the reward of the fourth unless I pay the price. Maybe that's what it means. Okay, so let's look here at some examples, because this is definitely a little bit difficult to understand exactly what it's wanting and what it's even meaning. So let's look at some examples, and hopefully this will become a little bit more clear. Okay, so input, prices. So we have 3, 1, and 2. All right. So it's not 1 indexed, by the way. It's 0 indexed. I mean, okay, so you are given an, not a 1 indexed, an 1 indexed integer array. And it's not 1. Fine, whatever. It's not. And look. Does that look 1 indexed to you? Does okay. Well, we're just gonna ignore that part. So it's 0 indexed, even though they specifically like bold. It's literally the first thing that they say, and it's in bold. So prices here. Output is 4. So this means that 4 is the minimum number of coins needed to acquire all the fruits. Okay. So if I purchase this one, so I have to purchase this one because I can't get the reward from any previous ones because there are no previous ones. So I have to purchase this one. So now this one I get for free, but I can decide, do I want to pay the price of it and get the next one for free, or do I want to just get the reward and then pay this price? Okay. Purchase the first for 3. You are allowed to take the second for free. So yeah, that makes sense. There we go. So I can get this one for free. I could, or I could pay the price. Which one do I want to take? Well, actually, I do want to pay the price, because if I pay 3 and then I pay 1, I get this one for free. So I save that 2 right there. So I pay 3, then 4, but I don't pay this one. Otherwise, I would have to pay this. So I have to pay 3. I get this one for free. And then I also have to pay for this one. So 3, 4, and then 5. So it's more. Okay. So this one looks like I want to pay the price for, I'm just, without looking here, I want to pay the price here. I want to take this one for free. I then want to pay this price and take this one for free. And so the output is going to be 2 right there. Yes. Now, so I think I understand what's going on. The algorithm. The algorithm seems to completely escape me. This is like a backtracking problem. Backtracking, the keyword is like find all combinations. I'm not seeing anything that says find all combinations. I'm seeing find minimum. It's a minimizing function or problem. It's a minimizing problem, therefore that should give me some indication of what I should use, what algorithm I should use. Okay. Return the minimum number of coins needed to acquire all the fruits. Can I I mean, backtracking, I think would work. No, I'm not even sure how I would implement that one. I mean, I guess. Yeah, I could implement it using backtracking, I think. And just have like some variable here, something. I'll just write it quickly, kind of. I don't know if it'll work. So like current min equals and then sum of prices, right? So I take the entire prices, and then what do I want to do? Def traverse, and then index. What it would be the base case is when I'm at the end of the list. So if index is greater than or equal to length of prices, and then whoops, and then up here I get length of prices equals len prices. Okay, so if it is the length of the price, what do I, or if it's if we've gone to the end of the index, that means we've gotten all fruits. No, I think I am going to be blocked in my future thanks. I need some way of determining if I'm allowed to even get something for free or not, because it's not. It's not. Okay, maybe I can do something like this, like, can use free. Okay, so this is going to be like the variable that I use to determine like, okay, this round for this index, can I actually use it? So, but if I've hit the end of the list, I know that, okay, I included all of the prices because I'm at the end. I'm out of bounds. Now, what I can do is I can check like if current price is smaller than current minimum, then current min equals current price. And now because I'm using this and this variable, I need to make both of them non-local. Non-local current price, non-local current min. Okay. So now current price equals 0, I guess. Okay. And so current price is going to be kind of like my sticky variable when doing the backtracking. So that's going to be accumulating as I pay and go through my list. And then it's going to be going away as I pop out and choose not to use one. Okay, so now what? If can use free. So if I can use a free one, I'm going to try to use a free one. So I am going to traverse index plus 1, and can use free is going to be false because I just used it. Okay? Now current price will stay the same. I'm not going to use my current price. Else, not else. I want to try doing this, okay? Then, if I can't do this, now it's time to pay the price of this item. So I've tried not paying the price. Now it's time to pay the price. Okay, so current price plus equals prices at index. And then I want to traverse index plus 1. And this one is now going to be true because I paid the price. Now I can use the next one for free. Okay. Then what do I want to do? I just want to traverse. And we're starting at the 0th index. And can we use the 0th index for free? No. So false. Now we return current min. We return the current min. Okay. And then I also just want to say, like, if not prices, then return. Oh no, actually that would work either way, because if prices is, there is no prices, prices is empty, it's going to come here, index is going to be 0, this is going to be false, it's going to come here, index is now 0, and price, length of prices is 0, so it's going to hit this case, it's going to check if current price, which is right now 0, is smaller than current min, which is sum of all of the prices, which, okay, that would also be 0. And so this actually wouldn't hit. But if this is already 0, then we're just returning 0 here. But I don't know if, can you use sum on an empty list? I think you can. So let's just see if that works, first off. No. Okay, what's going on here? List is outside the bounds of the array. So why? Oh, we didn't even return. Return, yeah. Okay, it's taken a long time. That usually means a timeout error. So I don't have much confidence. That's why I said, like, I think you can do it with backtracking. I just don't think it's a very optimized solution. And I got a wrong answer. So that, no. No. Expected 4. I got 5. Does it pass, like, what if I do, like, run? Does it just pass here? No? Darn. Okay. Why, though? Okay, so I want this is not going to run. I'm going to immediately add the price and then go to the next one. Okay, that seems right to me. Then I am going to come here. Now I'm at index 1. Okay, I come here. That doesn't hit. Can use free. Yep. So I'm going to come here. And I'm going to try to use it for free. What? Maybe I'm using this, like, current price incorrectly. What if I did something like this? Hold on. Whoops. Python is a hashtag. Okay. So what if I did, like, current price right here. And then I say current price is, we start at 0. And then if I can use it for free, we're going to just pass in current price. And then for this one, we're going to do not this, but we're going to go like current price plus prices of index. Does this? Oh, I should have just done run. That would have been easier or quicker. This is not a very quick thing. I just want to figure out if the logic is correct. I'm curious about that. Wrong oof, that is a very wrong answer. That's a very wrong answer. Okay, so the logic is even just wrong. Okay, so I was thinking about just like, can I even solve it? Like, not even focusing on efficiency. Can I even just use a brute force method? I don't even know how to use a brute force method on this one, let alone an optimized solution. Minimum. We're minimizing something. Well, I guess what that means is I want to do two things. The first thing is investigate what I did wrong with this. Like, what is my logic which is wrong with this? I want to figure out what my logic is when I use this non-local thing. And then I also want to figure out what the optimal solution is. So first we're going to test like what was wrong with this? Why does this not work? So here we go. What is wrong with my implementation of, put this in. Okay. You can use handling the, okay. Can use free condition. The logic for using the free reward is not correctly implemented, okay? Optimization. The backtracking solution can be optimized using dynamic programming. Okay, you know what? I think I'm going to stop doing heaps because this has happened so many times to me. And so what I said was I was going to focus on one topic, right? First I did depth first search. I focused on depth first search. I got fairly reasonable at depth first search. And then I said, okay, cool. I'm going to use the learn and forget method. I did depth first search. I feel pretty confident in it. I'm going to move to a different topic and I'm going to get confident in this area. And then that gives me some time to forget my depth first search. And then I'm going to go back to depth first search, refresh myself, and then I can move on to a third topic, right? And that's kind of how I was planning on doing that. And so I said, okay, cool. So I learned depth first search. And now which topic do I do after it? And I said heaps. Let's learn heaps, right? But what I'm realizing is every single time I do a problem, it's a different algorithm. I think what it is heap is a data structure. It's not an algorithm. So I keep coming into these algorithms that I don't know. Like this, whoa, like what did I literally just say? Like I didn't study dynamic programming yet. That's not one of my topics that I've even attempted to study. A few days ago, it was Dijkstra's algorithm. Okay, of course I haven't learned it yet. That doesn't even make, like, this is literally the exact thing that I was trying to avoid by targeting a specific topic. What I said was, when I first was doing LeetCode, I started these videos and I was doing kind of random, like this topic and then that topic. I was just doing every day was a different topic, and I said I'm not learning anything, or I was learning things, but I wasn't progressing quickly. I wasn't targeted. I wasn't utilizing my time efficiently because I was doing one thing and then I wasn't actually learning it fully. I was just going to a different topic and just topic. But heaps, I think this is why I'm having such problem with heaps. I've been doing it for what, 2 weeks now, and the last video I made, I think it literally was the last video, yesterday's video. I said I'm not improving. I don't know why I'm not improving. I think actually today, just now, I figured out why I wasn't improving because I'm a heap is a data structure. So that I understand data structure, or the data structure, which is heap. I know how to utilize it. I know how to it's a min heap structure. So therefore I need to negate everything so that when I pop, I get the largest if I that's what I'm interested in. The largest, if I'm interested in the smallest, I can just do it straight, right? So I understand how to use the data structure. I understand all of this, but I don't the data structures like used to implement an algorithm, and each algorithm is completely different, right? This one is dynamic programming. I haven't studied dynamic programming. Dynamic programming is an algorithm that I should dedicate an entire uh, a set of time, like whatever that is, like maybe it's 2 weeks, maybe it's 3 weeks, maybe it's 4 weeks, right? Like whatever it is, I should dedicate time where I just learn dynamic programming. Because if I do 1 day of dynamic programming and then 1 day of Dijkstra's algorithm, which I learned a week ago or maybe a few days ago, right? And then a little bit of this, okay, they all use the data structure heap, but I'm not learning quickly. And my entire thing is let's be efficient with our time, and this is not efficient in our time. Thankfully, I just realized why. Because I was struggling over and over and over with these heaps. I was like, why am I not improving? I'm not even getting any better. And that's, I think, why, is because each time I do a problem, it's a different algorithm that I haven't seen before, and I need to respect that algorithm and dedicate enough time to be able to actually utilize it. So I think that's what's going on. So moving forward, tomorrow, I'm not going to do another heat video. I'm going to figure out which topic I think is most important. And then, so I already did the depth first search. I think that was number one in the importance. That's a big one. So tomorrow I'm going to start a new topic, and I want it to be an actual algorithm. So that's what I'm going to be doing. Okay, so I guess let's just look at this. Again, I don't know backtracking, or I don't know dynamic programming, so it's kind of like, um, okay, so traverse. So they're still using this like recursion thing. If index is outside the bounds of the array and the current price is smaller than the min, then we update. Okay, so this right here is the same. Option 1 equals buy the current fruit. So this is the non-optimized one, I think. And then here's the optimized one. Okay, cool. So this one is more important, in my opinion. Obviously, the optimized one is the one that should have been used, right? But why do I say that this one is more important? What I mean is it's more important for my learning right now because I made a mistake with backtracking. I need to find what was my mistake. I need to fix my mistake, and I need to put it in my head like, hey, next time you do a backtracking problem, the danger for something, but I need to figure out what that something is so I don't make that same mistake. So this one I feel is more important. This one is, well, when I get there, right? Like when I get to the point where I used or where I study dynamic programming, okay, well then, yeah, I need to be able to implement this, but I haven't got there yet, right? So let's focus on our target here. So what do? So buy the current fruit. So I buy the current fruit, index plus 1, and then current price plus the price of that index. Yes, that's what I did here. And they are not using this like can use free. They're not using that. I don't know why. Use the free reward can buy next I fruits for free. Okay. For next index in range. What? Okay, hold on. Okay. So for next index is going to be, so there's going to be some iterable, and this is the iterable. Let me highlight what the iterable is. Here it is. Range returns 0, 1, 2, 3, 4, 5, all the way up to the stop, but not including. So next index is going to be just an integer of 0, 1, 2, 3, ascending. Okay. Now, what are we ranging through? We start at the next index. Okay. So it's not starting at 0, it's starting at index plus 1. Then can buy next I fruits for free. We stop at the minimum. Okay, so we're taking the minimum of what? Index plus I. Index plus I. Why would 2 times index plus 1 be our stopping condition? Or the last element in the list. That one makes sense. Why this? Okay. Traverse next index plus 1 current price. So we're going to traverse each node or each element after where we currently are. What a weird... This is weird right here. So understand how the free reward works. The purpose of this code is to handle the scenario where you can use the free reward option to get the next I fruits for free. This requires careful traversal through the fruit list to account for the free reward properly. Wait, hold on a second. The next I fruits? So it's not the next fruit, singular, after I. Oh. That's why it's 2 index plus 1. The next I. So it's you take where you currently are, you go that number of index to the future, and then plus 1. So it was just a okay, so I just didn't understand what this free reward thing was actually. I thought it meant like you could take this. Thought it meant like, oh, you can take whatever, this one, and then you get this one for free, and then you have to pay for this one, and then you can get this one for free. But I think what it means is you have like 0, 1, 2, and let's say I pay for this one. So 0, 1, 2, and then all of a sudden I can get this one and this one for free. And then I have to pay for this one. But when I pay for this one, this is 0, 1, 2, 3, 4, 5. And so then I get both of those for free or some. So that makes sense why my idea would not be working. Okay. So here's the dynamic solution. N is set to the length of prices, okay. Float infinity times n plus 1. Wait, why would I times infinity times anything? Infinity times anything is always going to be infinity. Unless it's like negative or 0 or something. So I'm creating a list. And in this list, I'm putting infinity in it. Then I'm multiplying this list by n plus 1. So, okay, what's going on in this line? Oops. What is going on in this line? Initializes a list called dynamic programming, okay, with the length of n plus 1. So I guess you can create, I thought you had to do like for something in. So I guess if you multiply it by n plus, I thought that just meant like multiply each element. But then in that case, it would be like one element in the list. But okay. So the expression float infinity, this expression represents positive infinity in Python. It is often used as a default value to indicate something. Yeah, okay, so it's obvious. It's just infinity. Okay, this is what we're more interested in. This creates a list containing n plus 1 elements. Okay, so I can just multiply it by some number. I can do a list multiplied by some number, and it creates a list of that number that many times. Okay. Is used, okay, so the multiplication operator is used to repeat this value n plus 1 times. Okay. So it's definitely a good thing that I saw it just now, because now I understand how to use it, and this syntax is not going to trip me up next time, right? It's good that I saw it. So the first one, the first element is 0. Okay. For I in range n, so we're going to be going through all of the indexes. For j in range I plus 1, so we're starting at this index and then going no, we're starting at 0 and going to that index, okay? If I plus j plus 1 is larger than n, this dynamic programming equals the min of this also dynamic programming. And I remember this is dynamic programming is one of those topics that I remember that I don't like. I don't know. I can't remember anything about it. It was what 3 or 4 years ago, when sophomore year. So whatever 3 years ago. I guess no 4, because I've been out of school for a year now. I just passed my 1 year anniversary as an engineer a few weeks ago. So 4 years now. But I remember I can't remember about why I dislike it, but I remember I didn't like dynamic programming. Something okay. So you're using the it's like filling out a table or something like that. I can't remember what it was, but it's okay. So there's the solution for dynamic programming. We haven't gotten to dynamic programming. That's not the algorithm that we're learning. Thankfully, we have now identified what the problem was and why moving forward in this heaps topic was so difficult. Because it's not an algorithm, it is a data structure. And so now we are no longer going to be working with these heaps. I need to figure out a new topic. And so tomorrow I'm going to be thinking about, okay, which topic here do I think is important? And then I'm going to be like targeting in on it, and I'm going to be trying to improve my understanding and capabilities in that specific concept, that algorithm. Because each of these algorithms needs time and needs a lot of attention, and you can't just do just one problem and then next day change and do another one and then another one and just randomly kind of do it. And by that time you did one over here, but then you did a whole like 5, 10 more somewhere else, and then you come back to this kind of algorithm, and then you've forgotten it and it doesn't stick in your brain. And so okay, my entire idea with these videos is kind of like document my journey of LeetCode, how I'm improving, and what my strategy is as well, because I don't want to be wasting time. I don't want to be wasting energy. I want to be able to just move through. I'm not obviously, as I show here, I'm not some amazing genius at doing LeetCode, right? And I just want to provide kind of an honest look at someone going through this process. Where are the pitfalls? How do you accelerate your process? How do you learn? What are some of the key concepts that are important? And this is kind of what I want to showcase. So, yeah, I'm going to be changing things up a little bit. And so, if that is something that you would like to watch or participate in or whatever, then subscribe to this channel. That would be awesome. I hope you enjoyed this video, and I hope you guys have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you tomorrow with a new topic. Okay.